So we have a position function. We're asked to discuss velocity. That means I need a derivative of the position function. So if I take a derivative with respect to t, this one has the power rule. The -2 comes down and multiplies. And then something called the chain rule should apply if necessary, where if you have an innermost function, you would take a derivative of the innermost function and multiply it, but the derivative of this function in here is 1, so that's not going to really impact what we do here. Okay, so they wanted velocity at t equals 7, so all we have to do is plug in 7 in for t. And then with my calculator, 7 plus 6, and then I raise that to the -3rd power. So that's like 1 over 13 to the 3rd, right? But we can just use the negative power part of our calculator. And we multiply that by 400, by -400, so that's -0.1821 to 4 decimal places. -0.1821. And now they're asking about acceleration. Acceleration is the derivative of velocity. So we need the second derivative of the position function. We're just taking a derivative of our function in part A. So that -3 comes down, multiplies. And then it gets reduced by 1 again. And then to find the acceleration at t equals 7, then we just plug 7 into our acceleration. So I'm doing 13 to the -4th power. And then multiply that by positive 1,200. So 4 decimal places, 0.0420 would be my answer here. Is the train speeding up or slowing down? So there's two different ways this could happen. You could be speeding up in reverse, or you could be speeding up going forwards, right? So if you're going in reverse, here, let's draw a quick train. That's my train. That's terrible. Okay, but if the train is speeding up going in reverse, then that means the first derivative would be negative, some negative number, right? Because you're going backwards. And then if it's speeding up, then that means the acceleration. So if we're speeding up in reverse, the slopes are negative, and the acceleration should be negative. And here's why. So let's write down -20 miles per hour. That's a negative velocity because we're going backwards. We're going 20 miles per hour in reverse. So this is s prime of t. And then let's write down -30 miles per hour. That would be speeding up in reverse, right? If you start going 20 miles per hour in reverse, which is dangerous in a car, and then you get even more dangerous, you go 30 miles per hour in reverse, you've sped up going backwards. And what happened between the first number and the second number? They didn't increase, they decreased, right? That's what acceleration measures, is the rate of change of the slopes. We went down by 10 units. We had a negative slope because we went down. So to speed up, the velocity and the acceleration need to be the same. Same thing with a forward velocity. If you're going forwards, then your velocity is positive, and your acceleration should also be positive. And here's an example. If you're going 20 miles per hour forwards, if you're speeding up, then your velocity should be increasing, right? Now you're going 30 miles per hour and 40 miles per hour. The rate of change of your slopes is 10 for this data set. It's positive 10. We're going up. So the rate of change of your slopes is positive. So these are conditions where you're speeding up. If you're slowing down, they're opposite signs. The first and second derivative are opposite signs for slowing down. So this says I'm going backwards, but this says my velocity is increasing. The second derivative being positive means I'm increasing. So this example would be like if you're going 20 miles per hour, and if you increased your velocity, now you're at 10 miles per hour because I added a positive 10. That's slowing down, right? From going to -20 to -10, we're slowing down. We're getting closer to 0. Same thing going forward. If the first derivative is positive, then the second derivative is negative. This is slowing down. Okay, so hopefully you get the idea. If the first and second derivative are the same sign, you're speeding up. If they're opposite signs, you're slowing down. So that makes our job really easy here. The first derivative is negative, second derivative is positive. That means we're slowing down, since the velocity and acceleration have opposite signs or something like that in this drop down.